Hey, welcome. So today, we're not really just doing math. Nope, we're actually on a mission. We're going to decode a secret language, a really cool puzzle that's been hiding in plain sight, right inside one of the simplest shapes you can possibly imagine. Let's get started.
So let me just start with a question for you. What if I told you that a basic shape, one you've been drawing since you were a kid, actually holds a powerful secret code, a code that could let you measure pretty much everything, from the height of a massive skyscraper to the distance to a far-off star, all without even leaving the ground?
Well, believe it or not, that shape is the right-angled triangle. It's our key. It's our Rosetta Stone, really. And over the next few minutes, we're going to learn its language together. We are going to crack the code of trigonometry.
Okay, so every secret code has its key players, right? Its main characters. And for our triangle, that means getting to know its three sides. Let's get the vocabulary down first, because trust me, once we know who's who, everything else just kind of falls into place. So here they are. First up, you've got the hypotenuse. This one's the superstar of the triangle. It's the longest side, and it's always just hanging out opposite that perfect 90-degree corner. Then you have the perpendicular and the base. Now, their identities, they're a little more flexible. They actually depend entirely on something we call the angle of reference.
So what on earth is an angle of reference? This right here is the crucial bit. It's really just the angle we decide to look from, our point of view inside the triangle. And get this, changing our point of view changes everything.
Now check this out. Our source material shows this perfectly. Take a look at the triangle on the left. If our reference angle is angle A, down in that bottom corner, then the side opposite it, BC, that's our perpendicular. But now, shift your focus. Look at the triangle on the right. If we look from angle C, up at the top, boom. All of a sudden the side opposite it, which is AB, that becomes a perpendicular. The hypotenuse never changes, but the other two, they totally swap roles depending on where you're standing.
All right, so we know the players now. It's time to learn the code itself. And this code is made up of three really special relationships, or ratios, that connect the angles of a triangle to the lengths of its sides. This, my friends, is where the magic of trigonometry really happens.
First up is sine, which we just write as sine. It's simple. For any angle you pick, the sine is always the length of the side opposite that angle, the perpendicular, divided by the length of the hypotenuse. That's it. It's a fixed relationship, a core piece of our code. Next, we've got cosine, or cos. This ratio connects the side next to our angle, the base, to the hypotenuse. So cosine is just the length of the base divided by the length of the hypotenuse. See? It's simple, it's elegant, and it's incredibly powerful.
And our third key player is tangent, or tan. Tangent is the ratio of the perpendicular side to the base side. You'll notice it's the only one that doesn't even involve the hypotenuse. And with these three, sine, cosine, and tangent, we now have the fundamental tools to solve a huge number of problems.
So, here's a quick little cheat sheet, just to lock it all in. Sine, perpendicular over hypotenuse. Cosine, base over hypotenuse. And tangent, perpendicular over base. This table right here, this is the heart of our secret code.
Okay, theory is great and all, but seeing the code in action, that's where the real fun starts. Let's take an actual problem right from our source material and use what we just learned to solve it step by step. All right, here's our challenge. We've got a right-angled triangle. We're told the hypotenuse is 13 units long, and one of the other sides is 5 units. Our mission, should we choose to accept it, is to find the values of sine, cosine, and tangent for the different angles. And the process is actually really straightforward. First things first, we need all three side lengths. We can find that missing one using the good old Pythagorean theorem. Once we have all three sides, we just have to figure out which side is the perpendicular and which is the base for the angle we're looking at, and then finally, we just plug those numbers right into our ratio formulas.
And look at this, it illustrates the results perfectly. So after using Pythagoras, we find out that the missing side, BC, is 12. Now we can calculate the ratios. For angle A, the sine is the perpendicular, BC, over the hypotenuse, AC, which is 12 over 13. But now check out the cosine for angle C. From C's perspective, BC is the base, so its cosine is also 12 over 13. How cool is that? The code works.
So, we've learned the terms, we've solved a problem. But what's the big picture? I mean, why does this ancient code of triangles still matter so much today? Let's get to the big reveal.
So what's the real superpower of this code? It's this. Trigonometry is a bridge.
It is the mathematical link that connects the world of angles to the world of distance. And what that means is, if you can measure the angle to the top of a building, you can calculate its height without ever taking a single step towards it. That's its superpower.
And I absolutely love this quote from our source material. Each trigonometrical ratio has no unit. Think about what that means. The ratio for a 30-degree angle is the exact same whether you're measuring a tiny triangle on a napkin or a vast triangle formed by stars in the galaxy. It's a universal truth.
So there you have it. The secret code of the triangle? Well, it's not so secret anymore. It's a beautiful, logical system for seeing the world in a whole new way. You have the keys now. The only question left is, what secrets are you going to unlock with it? Thanks for